Good morning. In the last session, we have discussed about a plus b plus a minus b minus that you can see over here. I just managed to write this text using this insert text box. Okay, so here you can write the sequence over here that will be considered as what your task for the experiments, so that it will be easy to get the uh, term work from your side. You can prepare the circuit diagrams like this, and you can submit it through Google link. So I will provide you the sequences for different batches, and also if you all, that is from third year A and B, that is both divisions, if you prepare this sequences in a group of five. I will provide the various sequences so that you can make practice of this, then it will be easy to prepare the circuit diagram in exam. That is for lifetime. It's not like that you can copy the solution from the available PDFs and you can pass the exam, but whenever you go for the job or any project work, then in that case it will help you to implement the logic that you have understood during this semester. So here this is for a plus b plus a minus b minus. Now I will make some changes. We'll see how we get the delay. So we'll introduce delay over here. Yes, delay in between this. So a plus b plus delay a minus b minus. Now I will tell you how to introduce a time delay wall and how to manage the inputs and outputs of the time delay walls. So here you can see time delay wall normally closed and time delay wall normally open. Normally open means whenever we actuate that wall, we'll see the working of this time delay wall by actually connecting with the circuit. But for time being, time delay wall closed means, and after actuation after actuation of that time delay wall, it will supply the compressed air after some delay. Okay, in case of time delay wall normally open, it will continuously provide it will provide it will continuously provide the compressed air for the next component, and whenever it is actuated it will stop the process after some time. So that is the difference in between the time delay wall normally open and normally closed. So right now what I will do, I'll just take the lines like this so that we can use this for getting. Yes. So first we will discuss about this, how the original circuit diagram will work. Now this is a 3 by 2 wall with push button. The output of this will go to AND wall. Since the last output or the process is B minus, B minus means the rod end of this cylinder will come to 2S1. So the output of 2S1 is connected to the one of the input port of the AND wall. So whenever it is pressed, the output of the AND wall will go, and it will be responsible for getting A plus, that is extension. That means initially over here 1S1 and 2S1 are pressed. So whenever the rod end goes over here at 1S2, 1S2 will get pressed and it will send there on the left hand side of the second 5 by 2 ball in order to get B plus. So whenever the rod end goes over here at 2S2, 2S1 will get unpressed. Now 1S1 is already unpressed, 1S2 is pressed, and after getting B plus, 2S2 will get pressed and 2S1 will get unpressed. Okay, so here you can see after getting B plus we want a delay, but before that how is the process? After getting B plus, 2S2 will get pressed and it will send the compressed air over here, and it will be applied on the right hand side of the first 5 by 2 wall. So here this side will get activated, and it will be responsible for getting redirection, that is rod end has to travel from 1s2 to 1s1. So while the rod end is traveling towards left side, 1s2 will get unpressed and 1s1 will get pressed at the end of the process. So then 1s1 will get pressed, and the output of that 1s1 limit switch will be applied on the right hand side of the second 5x2 ball over here. And then because of this, air will be applied on the right hand side of the piston, and hence rod end will come to 2s1 from this 2s2 position. So 2s2 will get unpressed, and then at the end of the process 2s1 will get pressed. So here the one cycle will be over. Now here, after B plus means after pressing of this 2s2, whatever the output that we are getting uh, at the end of completion, at the end of that second process, that is B plus, we must take a feedback from that position, and we must pass it through the time delay wall in order to get the delay. Okay, now I have introduced time delay wall over here. So what we have to do is the output of this, I'll delete this line. Feedback of this 2s2, I must connect over here. Then we will need one input from the, okay. So see, whatever I was saying, that is this is unidirectional flow control valve. Then opening level is 100%. Then we can enter the property. This is accumulator. That means first this air will pass through the flow control valve, and then it will go to this accumulator, and then after development of pressure inside the accumulator, there will be capable of applying pressure on the left hand side of this 3x2 valve, and already the air is coming at this input port of the 3x2 valve, that will pass further whenever this left side block is getting active due to application of pressure on the left hand side because of this unit. Okay, so once this pressure is applied on this side, the block will get shifted to this position, and air will pass from input side to the output side of the 3x2 wall, and then it will go further. Now initially this 2s2 was connected to this position. Right now I am just taking this time delay wall in between that path. Okay, means B plus to A minus was the connection, means feedback from B plus to start the A minus process. Okay, in the same way, feedback from this B plus to start a time delay valve, to activate time delay valve, and output of the time delay valve should be given to start the A minus. So 2s2 to this input port of the flow control valve, unidirectional flow control valve, and the output of this should be, okay, like this. I'll manage over here. Okay. So output of this is going over here at this right hand side of the wall. Okay, now this circuit diagram is complete. Now we can run this program. Open connections will be like this, superimpose components, yes. Now we'll go step by step. I'll press this. Okay, so initial at this first level, whenever we are pressing the push button, see which limit switches are in press condition, this 1s1 and this 2s1. Okay, so that's why the output is there from that those valves, those limit switches. So it is 1s1 is applying pressure on the right hand side of the second 5x2 valve, and this 2s1 is applying pressure on the right hand side. It is supplying the air on the right side input of the AND wall. Okay, I'll stop here. I'll just take this ball over here. This is over here. Yeah, fine. I'll run this now. Okay. Single step. Okay. So here you will see OS1 is applying pressure on this right hand side, and 2S1 is giving supply of air to the port 1 of the AND wall. Now whenever we press the push button, the left side block will become active, and in the next step you will see the air is coming out from that wall, and it is being supplied at the port 1, that is another input port of the AND wall, and the output of the AND wall is given to the left hand side of the first 5 by 2 wall. Okay, now here uh, this air, the air which we are supplying on the left side and on the right side, that won't go inside the cylinder. Okay, now which air will go inside the cylinder, that we are supplying at port number 1 to this air service unit. इथे air service unit connect केलेला आहे असं याचं meaning आहे. This is what the icon you can see here, compressed air supply. Okay, so just to avoid the complexity of the circuit diagram, a small icon can be given or can be connected to the port 1 of the uh, controlling wall. Okay, so here the air is coming and it is applying pressure from the left side. Currently the air was going inside the cylinder from the right side line, and left side line is exhausting the compressed air. Now on the next step you can see left side block will become active, and what will happen because of this, the air has to go inside the cylinder from the left hand side, and air has to from the right side come out from the right side, and that will be exhausted into the atmosphere to the port 3. Okay, uh, now just block active झालाय, current flow sorry air flow start झालेला नाहीये. You can see the air flow when this line is becomes dark. Okay, so here you can see now this, as this one is released after some moment, so this line won't have the air, also there won't be any output from the hand wall, but since this is, as this is double sided wall, once we are activating this left side, it will remain in active condition only. Okay, now single step. So something has happened. We'll see this again. Okay, we are pressing this. Then okay, it's not working in correct way, so we'll neglect that part. But it should be there. That is, this line, the left side line should become dark or blue, dark blue. But let it be. Uh, First, okay, here you can see. We'll see again. We'll stop this, we'll run this, we'll go one by one. After pressing this, we'll go stepwise. Here the airflow will come. We will apply pressure from the left side, then left side line will supply the air to the actuator or the cylinder. Then this line will become inactive. Then what will happen, the rod end will start moving towards 1s2 position. So 1s1 will get unpressed, means during that 1s1 will stop supplying the compressor which was applying pressure on the right hand side of this uh, 5 by 2 wall, second 5 by 2 wall. Now whenever the rod end reaches to 1s2, 1s2 will get pressed, and this air will be supplied on the left hand side of this 2s2 switch. Sorry, 1s2 will supply the compressor to the left hand side of the second 5 by 2 wall. And now what will happen, left side block will become active, and the air will go inside the cylinder from the left side, and right side line will exhaust the air into the atmosphere through port 3. Okay, and you can see the rod end which was present at the 2s1 will leave that position, hence 2s1 will get unpressed, and that will stop supplying the compressor at one of the input port of the AND wall. So this will result in unpressing of this 2s1, and after some time this 2s2 will reach to its position. The rod end will reach to 2s2 position, you can see, and that will get pressed. So when it is getting pressed, the left side block will become active, and the air will come out from that wall, and it will go to the time delay wall. Okay, input port of the time delay wall. It is having total two inputs. One is from the air service unit, second is from the pilot operated wall or simple limit switch. Then how it will flow, that we will see. Now immediately it will send the okay, I will have to stop this, and we should check the properties of this wall. mm, Opening level 50%. Okay, I should wait for the because this is a time delay wall, it will take some time to fill this accumulator. For the first time I'm using this time delay wall, so I think it may take time. We will stop this and we'll check the properties. Um, we might open level 100% and we will see what is happening there. So yes, not getting the solution, but what I'll tell you how it will work. So we'll go step by step till we get the output as per our need. So first I will stop this. Then we will run this. Uh, okay, okay, yes. Then we'll go stepwise. Then we'll press this. Then next step. Yes, we are getting A plus now. The A plus process will start now. Right now 1s1 is pressed, 1s2 is not pressed, 2s1 is pressed, 2s2 is not pressed. Mm, Supply will get cut. Uh, then next is this 1s1 will get unpressed. Rod will be in between the 1s1 and 1s2. Later it will reach to 1s2 position. Okay, so it will get pressed and it will supply there to this side. Then it will go. It will activate the left side block. Then it will go inside the air will go inside the cylinder, and air will go inside the cylinder, and it will start moving towards 2s2. Right now 2s1 is unpressed, 2s1 is pressed and 2s2 is pressed. So here 2s2 will now get pressed and 2s1 will get unpressed. So here the air will come out from 2s2, it will go inside the time delay valve. It will take some time to go through this flow control valve, and then it to fill the accumulator, and then later it will apply the pressure on the left side of this uh, 3 by 2 valve. Then the air will come out from this side and it will go on the right hand side. Then it has to apply pressure on this side. So here the air will go inside the cylinder from this side, and this is how it will go. And then it will take the piston on the left hand side. So 1s1 will get pressed due to that. 1s1 will get pressed and 1s1 will send the air on the uh, 1s1 will get pressed and it will send the air to the right hand side of this wall, and then 2s2 will get unpressed and 1s1 will get pressed. Okay, so finally 2s1 will come here. 2s1 will send the air to the input port of the AND wall, and then when we press this push button, it will remain in. It will send the air to this port 1 of the AND wall, and the next cycle will continue. So this is how it will work. Uh, so okay, some changes has to be there. Piloted by to it's correct. Properties, there is so much thing in the properties of time delay valve. We are given input also, so I'm not getting why it's not working properly, but it should work perfectly. But I think you have understood now how it will work in this circuit. So 2s to the air which is coming from 2s to will go inside the time delay valve. It has to pass through it, and then after some time, after some delay, it will send the air to this side. Then it will apply pressure. It will force the piston to move towards left side, and then it will come to this 1s1 position. To 1s2 will get unpressed, and 1s1 will get pressed. 1s1 is getting pressed means, and the air will come out. It will be applied on the right hand side of this wall. Hence, the rod end has to travel from 2s2 to 2s1. Means 2s2 will get unpressed, and 2s1 will get pressed. So you can see here also how this initially pressed is shown. Okay, initially pressed representation आहे. Never forget about this. Working of the time delay wall. We'll just check what if what will happen when we consider the time delay wall normally open. Okay. Hmm. Now it's easy to understand why it's not working. This is normally open time delay valve, means the air which is coming from this side, and that is from the air service unit that is coming on the right hand side of this valve. So the pressure is there on this side, so that's why it's not uh, it cannot proceed to the first, it cannot give you the first output, that is A plus, because since there is a pressure on the right hand side, by applying pressure on the left hand side, the story will not start. Okay, so this is not useful at all. um, we need to use this only 100%. And output of this is over here. Let's consider over here. So this is it for time delay valve. In the next session, we will discuss about electropneumatic systems. Here we can consider a unidirectional flow control valve in order to change the speed for the uh, movement of the piston or movement of the rod end. Okay, so I will show you where to connect. This is one way flow control valve. Okay, I will show here. uh, what we have to do is I'll delete this line. uh, we have to take the line over here, and the output of this should go over here. Then we have to show the properties as it's reduced to 50%. uh, okay, so this is 51. Means we have to change this by some value, so it will work like that only. Yes, you can see here how it's traveling. Here you can see how it's flowing. Some problem is there in case of actual in this side. Why it's not giving the output? Level it's 100%. It's not showing don't know whether it needs some more time or what is happening exactly. Okay, here you can see the difference in between the speed of this piston and this piston. Okay, I'll run this. इथे तुम्ही ऑब्झर्व करा की हा पिस्टन इमिजिएटली सेकंड मोमेंटला राईट साईडला जातो आणि इथे हा स्लोली जातो. दॅट यू कॅन सी फास्ट and slow. Okay, that is the difference. So for 100% it must go immediately. Okay, we'll opening level will make it as 10% now. 0.1%. 10%, and then we'll run this. Okay, okay, yes. Now it's taking time to activate that time delay ball. Here you can see how much time has elapsed after starting that, after pressing this button. Signal is not reaching to this point. If it reaches to this point, then everything will happen nicely. But that is only problem over here. So we will stop this and properties opening. We keep it as a 50%. Stop this and check the properties of this. This is spring return. We'll run this. We'll see what is the impact. Yes, this should be in press condition, but it's not remaining in press condition, so that's why it's happening like this. So you must check the properties. Mechanically operated, that is fine. Spring return, that is fine. Initial position, that is also fine. Okay, now we'll go step by step. Uh, we will see first, then it's going like this. Hmm. So whenever we keep this in press condition, yes, you can see the time. It's taking some time to take the air out from this, so I'll make it as a 11%. Okay, and then we'll check. Yes, it's taking so much time. Yes, exactly. So what we have to do is we have to press this. Now this is a software, so there is a problem that it won't remain in press condition. So we'll have to press this manually. There is some problem, so that's why we need to do this manually. Otherwise, rest of the system will work perfectly. Okay. So here we have to stop here now. So this is about flow control wall, connecting flow control wall and using a time delay wall. Now here also, if you want to make extension with a very varied speed, then we'll have to connect this flow control wall in this line. I'll stop this. If you want to connect this, you want to connect this in this line, then ही लाईन आधी आपल्याला काढायला लागेल. Delete this. Okay. Okay. Huh. Now here we have to connect this line over here and this over here. Okay. थोड़ा खाली घेऊया and you can take this over here. Okay, so see the way of connecting the unidirectional flow control wall in the line is इथे आपल्याला 100% वगैरे असं दाखवता येतं because this is a software. While drawing it on a paper, no need to show this as a 50% and 100%. It's just if you just represent the flow control wall, then it is self-explanatory. That is, the flow rate can be varied over this. So that's why whenever we want different speed for or varied speed for the A plus, we must connect the unidirectional flow control wall in this left line. If you want variable A minus, then we have to connect this in the right side line. Now this we have seen, this we have discussed. Okay. So here whenever we want to make A plus and A minus faster, like this, we can connect the unidirectional flow control wall for these two lines. Okay. So uh, if you want uh, A plus only as of maximum speed with maximum speed, then we have to connect the flow control wall over here and over here. Okay. So just like making a small line as a just like making a line as a small by drawing a longer line beside that line. Okay. So you can reduce the speed of the other outputs, other processes, because 6 bar 8 bar pressure will be the maximum pressure responsible for the maximum speed. So for the processes for which we have to vary the speed, we have to reduce the speed, or whenever we want to take whenever we want to perform any process with the maximum speed, then that 6 bar 8 bar pressure will be with the maximum speed. So other processes we have to slow down. So that is how we can use the logic. So thank you so much. For next session we will see about electromagnetic systems.